everyone, welcome to the chemistry channel. So today we're going to be talking about how to name inorganic compounds. So in the description of the video I'm going to try to put in a PDF file of these notes because there's a lot of typing in this lecture, and I think it would be easier for you to just print up the notes and follow along as we go. Because if I were to write all this out, the video would take a long time. And since it's all rules, it's mostly going to be your responsibility to memorize all this stuff and to practice it. So that's how I'm going to approach this lecture. I will try to post a PDF file of this online, and you can follow along that way. So with that, let's begin. So what is an inorganic compound? An inorganic compound is a compound that contains no carbon and no hydrogen. So it's a compound that contains no carbon and no hydrogen. Some examples include water, magnesium chloride, sodium chloride, hydrofluoric acid, another one would be hydrochloric acid, etc. So there's a lot of compounds out there that are inorganic. In fact, most of general chemistry focuses on these inorganic compounds. It's not until you get into, of course, organic chemistry that you really focus in great detail on organic compounds. So an ionic compound can be an inorganic compound. It usually is. It is usually a inorganic compound. So what you may recall from the last video that we talked at great length about ionic compounds. So all we're going to do is a quick review. So an ionic compound basically usually occurs between a metal and a nonmetal. So it is a compound made up of cations and anions. So one of the most common types of ionic compounds are, of course, when you have a metal and a nonmetal together. So here in this figure we have a very similar figure to the one as we did in lecture 5. So here we have potassium, a potassium atom, and a chlorine atom. So this is chlorine, and this is potassium. So what happens in an ionic compound is that the electron from the metal is lost to the nonmetal. So in this case the electron is lost from the potassium and goes on to the chlorine, which causes the metal, in this case potassium, to gain a positive charge, and the nonmetal, in this case chlorine, to gain a negative charge. The positive and negative charge attract each other, and this electrostatic attraction is the ionic bond. So therefore, if you aren't too comfortable with this topic, I encourage you to go back to lecture 5, ionic compounds, where I go into great detail about what ionic compounds are and explain how they are made. So in ionic compounds, metals tend to be the cation, so the positive ion, and nonmetals tend to be the anion, or the negatively charged ion. So now what we're going to do is get into the naming of these inorganic compounds. So I'm gonna be trying to post a PDF file of these notes. So the best thing to do would be to print up those notes and to follow along as we go, because a lot of this is already pre-typed by me, because it's a lot of rules, and if I were to write it all with my pencil, it would take a very long time. So I encourage you to print these notes and to follow along that way. So here we have the first thing that we're going to talk about, which is naming cations. So what is a cation? Well, a cation is a positively charged ion, right? So in ionic compounds, metals tend to be the cations, and there's some rules about how to name them. So generally speaking, if you have a metal cation, the name of the metal cation is the same of its corresponding metal. However, there's some specifics with how you have to name the metal depending on its identity. So the first rule is that if a metal has only one possible charge, if it can only form one type of charge, we can just write the metal name and then the word ion after it. So you can use this rule to write ions from the group 1 metals and group 2 metals. So this will work for the alkali metals and the alkali earth metals. So some examples include sodium ion. It can only form a +1 cation, so we can write sodium ion. Now, if you have magnesium, that's an alkali earth metal. It can only form a +2 ion, therefore we write a magnesium ion. And if we have a potassium, it can only form one type of ion, the positively charged ion, the +1 ion. In this case, you say a potassium ion. So that's what you do for if a metal has only one possible charge. So how about if a metal can form multiple charges? Well, if a metal can form multiple different charges, you must indicate the charge in Roman numerals after the metal's name. So it's a good idea to use this rule for all of the transition metals. And that's because transition metals can form multiple charges. So this means charges. So one great example is iron. So iron can form both a +2 cation and a 3+ cation. In order to differentiate between the two, you would say for the +2+ cation, iron 2 ion. And in order to differentiate the 3+ ion, you say iron 3 ion. So those are the general rules for metals. Now, it's important to note that it is never wrong to write the charge after the metal. If you are ever unsure about whether a metal can form multiple charges, feel free to write the charge after the metal name. In other words, it's never wrong to write the charge after the metal. It's just unnecessary for metals that only form one charge. But if you're ever unsure, if you're ever nervous, just feel free to put that charge after the metal. So believe it or not, nonmetals can also be cations. So if a nonmetal is a cation, it has the ending ium. So some great examples are these two. So here we have NH4+. This is ammonium. So notice the ium. Here is a common compound that you will see in your acid-base chemistry. So you're going to see this a lot in general chemistry too. This is called a hydronium ion. So these are both ions, so I'm going to put ion here. Now your professor probably has a list of nonmetal cations that they want you to memorize. So my best advice to you would be to make flashcards for those and to memorize the ones that they want you to memorize. But these are two very common ones. So now let's get into naming anions. So anions have a lot more variation than cations do. So we're going to start off with monoatomic anions. So monoatomic means one atom anions. So they're literally made of one atom. So in order to name a monoatomic anion, replace the ending of the element with "ide." So here we have a couple of examples. So here is a fluorine ion. So we'll write fluorine. However, in order to correctly name this, you cross out the "ine" and add "ide." So fluoride ion. So this is a fluoride ion. So here we have a chlorine. In order to name this, you would get rid of the "ine" and add "ide" at the end. So chloride ion. So that is the chloride ion. So you do this for all your monoatomic anions. However, it's not always that simple. You also have polyatomic anions. So what does poly mean? Well, if you are in organic chemistry, or if you ever took biochemistry or a biology course, you'll know that poly means many. So these are many atom anions. So these are many atom anions. So the first type of polyatomic anion that we're going to be talking about are the oxyanions. So oxyanions are polyatomic anions with oxygen in it. So these have oxygen in their chemical formulas. So the example we are going to use is the anion chlorate. So this is chlorate. So this actually brings up our first rule. So the first rule for naming oxyanions is to replace the ending with "ate" for the most common oxyanion. So the most common oxyanion with this charge, in this general formula, ClOx, so we'll just write ClOx. So it will have differing amounts of oxygen, but the same charge, so the same negative charge. So the most common oxyanion is in fact this one. So in order to name the most common one, you put "ate" at the end. So you can start off with chlorine, cross out the "ine," and get chlorate ion. So that is the name. And this is actually one that you're going to probably want to memorize because it's very common. So the next rule is to replace the ending with "ite" for the oxyanion that has the same charge but one fewer oxygen than the most common oxyanion. Now applying this to this oxyanion, one fewer oxygen atom would be ClO2 minus, and it has the same charge, notice. In order to name this, let's write our base, so chlorine, get rid of the "ine, and add "ite." So this is a chlorite ion. So the next rule, add the prefix "per" and keep the ending "ate" for the oxyanion with the same charge but one more oxygen than the most common oxyanion. So in this case, remember the most common one was ClO3 minus, so one more oxygen would be ClO4 minus. Therefore, this would be called a perchlorate ion. Now the last rule for, let's actually box this a little bit better. So this is a perchlorate ion. So the last rule is to add the prefix hypo and keep the ending "ite" for the oxyion that has the same charge but two less oxygens than the most common oxyanion. So the example would be here ClO minus because it has two less oxygens than the most common one. So therefore, how we would name this is hypochlorite ion. Now it's important to note that these polyatomic ions that I just told you about, you should memorize because these are very common ones, and it's probably one that your professor will want you to memorize anyways. And there's a whole list of them that you should memorize too, so make sure to go through your professor's notes and see which ones they want you to memorize. So next we're going to talk about naming polyatomic ions with H+ attached to the oxyanion. So in order to name these types of polyatomic ions, you add the name hydrogen in front of the oxyanion name, and if you have multiple hydrogens, indicate the number of hydrogens present with the prefix di, tri, etc. So one example would be HCO3 minus. So HCO3 minus. This polyatomic ion here is called the carbonate ion. So CO3, let's write this here, is -2. So this is CO3 -2. So let me just rewrite this. This is another polyatomic ion that you should know. So CO3 2- is carbonate. So in order to name this, all you would say is hydrogen, carbonate, ion. So that's how you name this. And if you had, let's just say 2 hydrogens, you would say dihydrogen, 3 hydrogens, trihydrogen, etc. So that's pretty easy, right? So now we get to put all we learned together. So naming ionic compounds, in order to name an ionic compound, you have to use all the rules that we talked about above in order to name the full compound. So how about this? How about you pause the video and attempt to name all of these compounds that I have written here by yourself. So I hope you pause the video, so let's do this. So you have sodium and fluorine. Now the sodium only forms one charge, so you can just write sodium if you want. However, remember you could say sodium 1. However, I'm not going to write that because sodium only forms one charge. And then you have the anions, so fluoride. So next we have magnesium and 2 fluorides. So magnesium only has one charge, so we can just write magnesium if you want to. And since you have fluorine here, we have the same name, so magnesium fluoride. So the next one, you have to be careful here. So I should have had a 2 here. So sorry if you got a little confused. So here we have an iron and a chlorine. So remember, the tricky thing here is that iron is a transition metal, so therefore you have to indicate the charge. In this case, it's +2, so it's iron 2 chloride. So the last one is the trickiest one. You have calcium, which is a group 2 metal, therefore it only forms one charge, which is +2, and the perchlorate ion. So in order to write this, you write calcium perchlorate. And then you're done. So ionic compounds are not that too bad to name, right? So those are the general rules for ionic compounds so far. So now let's get into the naming of acids. So quickly, let's define what an acid is. Now, take note though that acids, we don't really get into acids too much this semester. You're going to get a lot into acids in the second Gen Chem, in Gen Chem 2. But an acid is basically a substance that produces H+ ions. So it's a substance that produces hydrogen ions in water. So that's all you need to know about an acid for right now. you're going to get way more into acids when we get into general chemistry 2, and I think a little bit in general chemistry 1. So let's talk about how to name an acid. So when an acid has a monoatomic anion, change the ending of that monoatomic anion from "ide" to "ic." But however, you also add the prefix hydro to the beginning of the name, and then you add the word acid at the very end. So one example would be, of course, HCl. So here we have the chloride anion, right? Because this is the anion, this is the cation. And in order to name this, you would drop the "ide" and put chloric. And then you add hydrogen in the front. Hydro. So hydrochloric and then acid. So hydrochloric acid. So another one would be HF. So in this case, you have fluoride, drop the "ide, and then you call it hydrofluoric acid. Oops, let's circle that a little bit better. So hydrofluoric acid. And that's how you name acids with monoatomic anions, okay? All right. So when an acid contains a polyatomic anion, it depends on the anion that you're talking about. So if the original ending was "ate," you convert the ending to "ic," and if the original ending was "ite," convert the ending to "us." So, however, for both, you have to add the name acid at the very end of the word. So here, you'll recognize these as the same example that we had above. So do you remember what this species was? Hopefully you said perchlorate. Therefore, in order to write this, you drop the "ate" and put "ic," so it's perchloric acid. So please note that I don't put hydroperchloric acid. It's just perchloric acid. So the next one, can you tell me what this one is? So hopefully you said chlorate. So this is chlorate. So you drop the "ate" and write chloric acid. So here we have HClO2. So can you tell me what this is? Hopefully you said chlorite, so therefore write chlorite. Therefore you drop the "ite" and write "us," so it's chlorus acid. So chlorus acid. So the last one, hopefully you know what this one is too. This is hypochlorite. Therefore, you drop the "ite" and you say hypochlorous acid. So hypochlorous acid. And that's how you name these polyatomic anion acids. Okay. So the last little bit we have to talk about is the naming of binary inorganic compounds. However, these ones are non-ionic. So here are the rules we have here. So the first rule is that the element closest to the metal side of the periodic table is always written first. However, we have some exceptions. When the compound contains oxygen and chlorine, oxygen and bromine, or oxygen and iodine, you put the oxygen at the end of the word. So those are the exceptions. So for these, you put oxygen at the end Normally it would be written first, however here it's not. So when two elements are in the same group, the element closer to the bottom of the periodic table is written first. Also, you always indicate the number of each atom using the Greek prefixes of di, tri, etc. So di, tri, tetra, penta, hexa, hepta, octa, nona, deca, etc. So, and then the last rule is that the second element is given an ending "ide." Okay, so let's do one example. So Cl2O. Now, normally you would write oxygen dichloride, right? However, this is not the case for this chemical species because it is one of the exceptions. So you would have to write it as dichlorine monoxide. So you add the "ide" to the end and put the chlorine in front. So that's it for all of the rules that I talked about. So hopefully you got something from this lecture. And here I have some practice questions for you to do. So I encourage you to pause the video and try them for yourself. Okay, so let's do this. So this polyatomic anion here is actually called, if you probably had to memorize this one, is called the sulfite ion. And that's because SO4 2- is the most common, so that would be the sulfate, but this is the sulfite ion. So this one here, you have water, but that's not the correct name in this case for it. In this case, since hydrogen is the closest to the metal side, that would have to go first. So you would call this properly dihydrogen monoxide, using the rules that we talked about above. So the next one is this Br2O. Now you have to be careful with this one because this is one of those exceptions. So in this case, you would have to write the bromines first. So you would have to say dibromine monoxide. Okay, so here is a polyatomic acid. This is the most common form of that acid. So what you write is sulfuric acid, and that's because this is the sulfate anion, therefore you replace that H with ic and add acid at the end. Now the last one here is N2O4. Nitrogen is closest to the metal side, so this has to be written first. So you write dinitrogen. And you have 4 oxygen here, so it's the prefix tetra, but in this case you would say tetroxide. So dinitrogen tetroxide. So that is it for this video. So once again, I will try to post these rules, these notes online, and I hope to see you in the next video. In the next video, we're actually going to be starting real chemistry when we begin to talk about some different chemical equations, balancing chemical equations, limiting reactants. So we're getting into real chemistry soon. So I thank you for watching this video, and good luck, and I hope to see you soon. See you guys.